This question is from GATE 2022 Mechanical Engineering Paper Set 1, question number 39. Consider a forced single degree of freedom system governed by x double dot of t plus 2 times zeta omega n x dot t plus omega n square x of t is equal to omega n square cos of omega t, where zeta and omega n are the damping ratio and undamped natural frequency of the system, respectively, while omega is the forcing frequency. The amplitude of the forced steady state response of this system is given by 1 minus r square whole square of it plus 2 times zeta r square of it raised to minus 1 by 2, where r is nothing but omega by omega n. The peak amplitude of this response occurs at a frequency omega equal to omega p. If omega d denotes the damped natural frequency of this system, which one of the following options is true? Let's find out. Now there are three frequencies involved in here. One is the damped frequency omega d, the other is forcing frequency omega, and natural frequency of the system omega n. It is given that response of the system will be maximum, that is amplitude of response will be maximum when this omega is equal to omega p. And now we are being asked to find out the relationship between omega d, omega p and omega n. Let's do that. We'll first write the given things. So forced steady state response, let's denote it by x, is given as under root of 1 minus r square whole square plus 2 times r whole square. Now we are being given that for the peak amplitude of this system. So focus on the word peak amplitude. It is not this forced steady state response which is maximum. It is the amplitude of the response that is maximum, which is given by A equal to, for a forced single degree of freedom system, we calculate it as F naught, which is the amplitude of the force, external force, upon stiffness of the system K divided by this term X, which is the steady state response. 1 minus r square square of it plus 2 times zeta r whole square. Now we know that for A to be at its peak value, this denominator should be minimum. And here's where there are high chances of making a mistake. This being in the denominator, that should actually have a minimum value here. Now to minimize x, we can minimize this inner value also, because if the inner term is minimum, under root of it will also be the minimum term. And therefore, we find the derivative of this term with respect to r and equate it to 0. Doing that, we have 2 times 1 minus r square into derivative of this term by chain rule. So we have into minus 2 times r plus derivative of this second term here will be 2 times 2 zeta r into, again the derivative of the inner term will be 2 into zeta. This should be equal to 0. Let's simplify this. We have 2 into 2 is 4 and minus sign taken out. We have minus 4 times r into 1 minus r square plus 2 into 2 is 4 into 2, 8. 8 zeta square into r is equal to 0. So rearranging the values and cancelling out the common terms, we will have 2 times zeta square is equal to 1 minus r square. So here we will have the value of r square as 1 minus 2 zeta square. Now we need to find out the relationship between omega values. So omega d, omega p and omega n. We need to therefore bring in omega somewhere here, and we know that r is given to be omega by omega n. And peak amplitude, where we have substituted this, omega is nothing but omega p square of this term, which is equal to 1 minus 2 zeta square. From here we can write omega p will be equal to, taking under root, so under root of 1 minus 2 zeta square, and omega n was already square, so after taking under root we have this term as omega n itself. Now taking the value of damping ratio zeta should be positive, and therefore it will be greater than 0. Omega p should be less than omega n, because we are multiplying a value less than 1 to omega n, and therefore omega p always have a lesser value than the natural frequency of the system omega n. So we have a relationship between omega p and omega n. We need to now connect damped frequency to it. So by definition we have that damped frequency omega d is given as under root of 1 minus zeta square into omega n. So from here clearly we have omega d is already less than omega n. Combining these two conditions we will have omega n is the maximum value. Now we need to decide between omega d and omega p which is the bigger one. So considering these two coefficients we clearly know that this one's the smaller. So omega p is the smallest value and omega d will be placed here. This is greater than omega p. Let's go back and mark this option. So clearly we can see that our answer is option A, omega n being the greatest value, omega d is in between and omega p is the minimum one. To learn more about forced vibrations, you can refer to the NPTEL video Module 2 Lecture 8 L8 Forced Vibrations Dynamic Magnification Factor. This lecture is from the course Soil Dynamics. The course is taught by Dr. Deepankar Chaudhary. He is from Department of Civil Engineering of IIT Bombay. I hope this solution helps you clear your doubt. Thank you.